What's up, everybody? Today, we're gonna get some headlights on this thing, finally. I hope. Kinda looks like an egg. How's it going, guys? Welcome back to Make It and Break It. My name's Andrew, and behind me is our Project HyperTenere Yamaha R6. We've been struggling the last few weeks, actually, trying to figure out a way to mount headlights and our instrument cluster on the front of this thing. We're basically, holy crap, I basically want to replace this, which was the old headlight mount instrument cluster piece that sat on front here somewhere. But once you're sitting up and you have a more comfortable seating position and your feet are in front of you and you're standing up, this is a very bad place to put your controls. As well as it just sticks forward and keeps that low slung sport bike look that, I mean, doesn't really work for an adventure bike. So I have been struggling and printing and designing for weeks now, trying to figure out the solution. And the result of that is this giant pile of broken dreams. So this is, well, I mean, not that. That doesn't belong here. But the rest of this is 100% just designs after designs of headlight mounts and other mounts to mount these headlights and that instrument cluster on the front of that bike. So let's take you through a quick timeline of that event, stuff, things. No. Events? I said that already. Anyway, let's take you through that real quick. And then I'll walk you through what I think we're actually gonna do and why we're doing it. Okay, quick history of failures in design for our motorcycle. We started with this. This is the normal front end mount structure. It's made out of aluminum. Looks like it's cast aluminum. So it sets up here, headlights go in here, instrument cluster goes here, fairing comes up and over like this. And the intakes kind of come around here and mount right up here in front. It works very well at what it's supposed to do, which is protect the rider when he's down in a tuck off of the tank, provide a relatively clear view of the instrumentation at that sort of riding position, and get the intakes and headlights out front where they're best, especially those ram air intakes. We've gotten rid of those now because we don't need them. But this is what we're replacing. And now is the trail of great ideas that just don't work. This is why mechanics hate engineers. I'm gonna let you in on a secret right now. I'm an engineer, or at least I have an engineering degree. And this process is why mechanics and people who want to get stuff done hate engineers. It's because we go through a lot of these iterations and a lot of them are really terrible. Unfortunately, companies don't necessarily have enough time to wait for us to come to the correct iteration, so we put out something that's probably just good enough, which is where we're here at the end. But we started with this. You guys might remember this. This piece sits right in here, and this was purely a location piece to try and locate where we wanted our instrument cluster, because I figured it'd be real easy to bolt on the headlights. It's not, but I figured it'd be real easy to just figure out a headlight mount and off we go. Cool. This was a good plan. This was the last good plan. I just made it in that. the coolant bucket over there. I just tossed that Okay, cool. On that note, so then about a week and a half later, you guys saw this when I was messing with the headlights, and I came up with this design. This is actually well, it was originally a one-piece design. It was this mount that goes in here. You can see kind of the setup here. This is just to hold everything stable. This is not actually how it would have been. This mount to go in here and hold the headlights in with our brackets that come with the LED lights that we're using. That goes there. And this was our instrument cluster mount, which is kind of up here in roughly the same position. Couple things. This still hit a bunch of stuff around here, and we couldn't print it. I think it had something to do with the way the models interacted in some weird spots, but we essentially failed at printing this many times over. So we abandoned that and went on to, where is it? This one. I don't know why it still has crap in it. Excuse you. Give me that. Good. This one. So this was our first attempt that we actually successfully printed of a fully enclosed and ready to go front sort of rally tower, essentially. That's what we're building here, is we're building a rally tower. And the idea is each one of these slots, one of these headlights would slide in here into each one of these slots, and then there's little holes in here, and the whole inside of it is hollow. So we could use the inside of it to like contain all of the wiring and everything that goes up front here. And then up top, you see all this mounting thing. That's for the instrument cluster. That was the idea. Problem is, it didn't print very well. You can see this cracked here and actually here, cracked in a couple spots. And the design was just, it took too long and it took too much material to print. This was nearly 1 kilogram of plastic once we were done with supports and everything else. So this was a decent idea, but not a great idea. It also relied on kind of the weak points of plastics. In order to print this in any sort of reasonable way, we had to subject a lot of forces along the weak spot of our plastic. If you want to know more about why 3D prints are weak, there's a video somewhere up here, maybe I'm pointing to the correct side this time, that talks about anisotropic material properties and why 3D prints have that. So we had a possible solution here, I thought, and this one failed. Then we finally came up to, well, it was functionally the end of this design space, which was this one. So this one looks very similar to the other one, except for a few key details. You can see all of these mount right here. These have a lot more clearance between the back here and all of our turning stuff, so they don't contact any of the spots and pieces that the motorcycle is. It keeps it relatively short up here, and it changed. So here's your housing for your lights again, right? Same similar design, but this one was a little bit easier to print because of these cutouts, and we had some better routing for cables. Problem is, you can see this thing broke because we were still loading it in the weak direction of our material, and there's really no way to get around that. And I had been attacking this project as a way to 3D print some very functional strength items. And if I had had maybe some carbon fiber nylon or continuous fiber printer material, this might have worked. I could have oriented it on the print surface such that it really didn't run the same sort of risk of cracking like a lot of this stuff did. Even though this is only PLA, even polycarbonates and nylons would have probably separated in roughly the same way. So I had to scrap this idea, and this was last week, I think, sometime, when I just figured out this idea is just not gonna work. And that left me in a bit of a pickle because I've already spent, I think, more than I wanted to on this bike project, just to, because I wanted to keep it like, hey, you've got this spare bike laying around, you don't have to spend you don't have to spend a bunch of money, and you can get yourself a bike that'll go anywhere and do anything. And like, this is, you know, maybe $100 worth of metal overall between what we purchased and just had it laying around. But I don't want to go out and, well, nobody makes a rally tower for this bike for obvious reasons. Nobody rallies sport bikes. And I really want to just stop ordering $35 parts. I've got one more set of things coming in that are just for clearance and protection on the handlebars, but I really want to just stop ordering $30 and $40 parts and use what we had left. And what we had left is, well, there's not a whole lot. We have some aluminum plate, we have some steel, and we have our 3D printers. And I wanted to use those somehow, some way, to build us our front mount system without just going out and buying all sorts of new headlight mounts and turning signal mounts and handlebar clamps and everything else in that frame. So this is what I came up with. So these are flat 1/8 inch pieces of polycarbonate, and this is a 1-inch steel tube. This is in fact the same steel tube that we made our crash protection out of. And the idea here is pretty simple. We're struggling with a lot of stuff that we want to be centered, but if we don't really have the tools, well, press brake, the right size metal to make a fully, you know, sheet metal, thin plate rally style front tower. So what we're going to do is make it in sections and connect all the sections together with steel tube. That means this is going to become our mounting system here. So each one of these little plates is actually going to be 2 pieces of steel plate once we cut them out. But we have one piece here, right up on the front, that mounts everything up off the bike. Then, seeing these round holes, I hope you see where we're going here, we take a main spar here of our tubing that goes through here, right? And on this spar, we stack our instrument cluster mount and our headlight mount. So this headlight mounts both LED headlights here, and it mounts them so that we can adjust them appropriately. And so this will mount somewhere out here, and this one will mount somewhere in here, and then we'll weld everything in place once we have everything where we like it. And there will be a mirror of this side over up on this side, and then we'll be able to like weld these things together with a plate that we mount the instrument piece on, and these things will be held together by the weld and by the headlights that run between them. So we end up with a weird sort of scaffolded version of a rally tower. And the handy part about having a 3D printer like this is, well, this one I already checked fit, and these holes are too big, but I got a new one coming off the printer very soon. I can print these parts and then use them as tracing templates on our steel plate. So what we're gonna do is pull these parts off, trace the outlines, get everything cut out, and come on back here and see what it looks like.
Waking up anew, wasting time is all I do. But now when I'm with you, so much time, nothing to do. I'm dropping you texts now.
I want to take a quick break and show our progress, which is very good. We've got our first rough cut versions of the main bike mount. So this is these little like LV bracket things come up here, and we've got everything bolted in, and this thing slides really well and easily. It actually slides easier than I thought it would. So that's entertaining. But everything here looks to be like fitting perfectly, which is what we wanted. So now that the holes are all in the right spot, we can clamp these things back together and smooth out the edges so they're at least a little bit more, you know, uniform and not looking like they just came off of a bandsaw. I did want to go over my process here real quick. I built all of these things, and I'm still working on the last ones. Maybe you'll see the time lapse or not. I built all of these things indexed off of this pipe location. So specifically, I clamped down and drilled through to locate this pipe. Well, not this one, but the pipe that's going to run and make this central spar on our tower here. And I'm going to use that to locate everything else. So basically what I've been using is this little short piece of tube here as kind of like my alignment check tool. If it goes in and moves nice and easily, everything's lined up well. And then I can drill my next holes, like the mounting holes here, or the holes on the on the light mounts, the adjustment holes. So I can drill all of those in pairs once I have everything lined up to this hole. And once everything comes back here, everything should line up just fine. And this does all of the work for the alignment for all the pieces. So let's go finish that up and do a little cleanup on the edges here. All right, so we finally got everything in here. This is our final sort of mock-up, check fit to make sure everything works. And it doesn't look too terrible for something I threw together from scraps that I had laying around the garage. So that's actually pretty encouraging, I gotta say. So, how we have this set up right now, we've got our lights in here, and well, I actually wanted to do a proof of concept here. So these lights have adjustments on the side. That's just to help me out in case I move them around or go with slightly different set of lights or something like that in the future, so that I can move these things around and adjust them to point them where I want to go. I have them adjusted fully up, and this is down as far as it will go. Don't fall over yet. This is essentially the light mounting system here is tabbed down as far as it'll go. And these things still do shoot upwards. So we have plenty of adjustment on here to get whatever we want out of our lights, which is nice. And then this is our instrument cluster setup, which is looking pretty good right now. The key here with this assembly is everything keys off of the alignment here with this rod. And so that's why we bored those holes first with the rod. And that's why we kind of use that rod to set up and align everything else. And that makes it very hard for some of these pieces that are separated plates, like this plate and this plate are 8 inches apart from each other, but we need them to line up around this hole. So close enough that we can weld it, and these things will move once we're done. So it's gonna be a bit of a process, but for free $99, I'm willing to go through a little extra effort. So let's stop talking about it and let's get this thing fully welded and check it out in its final form. Well, all right, and we're done. We got this thing back on here, and it's pretty freaking sturdy too. I guess that's what happens when you make a mounting bracket out of 1/8" plate. And 1/8" thick, or basically crash bar tubing. So it's maybe a little over strong, but I don't think that's gonna go terribly. And we got everything in here, and it seems to work pretty well. All the lights move around like they should in the orientations they should, and this fits in here very good. I installed it in the wrong order, so I couldn't fully seat it in there properly. And even our all of our wiring and stuff for the front kind of hides up here really nicely. So that's encouraging to see too. So I'm actually very encouraged by this. You can even see what it looks like turns on. And right now I have the main headlight on top. I'm not sure if it should be on top or on bottom. I'm undecided there. And then this one goes on as well. You can see that thing's ludicrously bright. And everything's pretty much straightforward, and I have a bunch of room to adjust it and aim them where I want them to go. So overall, I'm very happy with how this thing turned out. Let's turn this off for now. This is one of the bigger remaining hurdles to getting this thing roadworthy and well, trail-worthy too. So hopefully in just a little bit of time we're going to be able to throw this thing onto some dirt trails and see how she does. So yeah, that's it for this episode. Thanks for watching, guys. My name's Andrew, another Make and Break YouTube video on our Project HyperTenere. Like, comment, subscribe, do all the YouTube things, you know the drill. And come on back for the next time we do some more stuff on this bike and hopefully start getting her out and getting her a little dirty. So until then, I'll catch you guys later.